Okay, so I tried to zoom that out a little bit, but it didn't really work that well. But anyways, today we will, oh, sorry, I haven't made videos a lot. I've been waiting on a part for the big 3D printer that just came the other day, so we'll be finishing up that soon. But unfortunately, there's still electronics that need to be done for the big 3D printer, and my soldering iron, which is this, a TS100, failed when I went to go use it the last time. So let's talk a little bit about this. Most of you guys are probably familiar with the TS100. It's an excellent soldering iron. It has cartridge-style tips. So the heater is actually embedded in this whole thing. So if you want to change the tip style, you have to change the heater and stuff, which makes these tips significantly more expensive than the traditional style. But these heat up much faster and have much better thermal characteristics. You can see here it is inserted, and it would normally have this cover on, but there's a reason why it's off. Because again, I discovered that this had failed. And let me demonstrate how it failed. Here, we'll actually just put it this way, because there's not much useful on the screen. It just says error, which is kind of obvious. It's kind of obvious that there's an error. Well, first, let me actually take a few measurements with the multimeter and see if you can guess what's going to happen. So here we go. Here's my multimeter. Set it to ohms first. So, if you guys don't know how heater elements work, heater elements are just... Oh, it's hot already from when I had it plugged in for like 2 seconds. Wow. So, if you guys don't know how heaters work, heaters are just resistors. And resistors... and you can use Ohm's law to calculate how many watts of heat a resistive heater will produce. So the way these TS100 tips work, which actually I have a good one, so I can tell you what the resistance is. 1 second. Here we go. So the way these TS100 tips work is they act as a resistive heater. So here's my good tip. This is a canonical tip, and I'm going to use it occasionally, but I mostly prefer this tip, which is probably why this tip failed, because it has a lot more use on it. This canonical tip, if we were to measure, can't see the display because I'm measuring on top of the multimeter, between these 2 points, I can't read it because it's upside down. Let me look at the screen where you guys can see it, hopefully. 8.9 ohms, it looks like. So, about 9 ohms. And then you could use Ohm's law and put the voltage going into the TS100, which is 24 volts coming out of this plug. And the resistance of this to find out how many watts the heater would produce. At full power. But of course the TS100 has a Mosfet right inside of it, right here, and this Mosfet controls whether or not this tip is receiving 24 volts at any particular given time, and it rapidly switches that on and off in a it is pulse width modulation, but I'm trying to think of in a PID loop. According to the microcontroller, which is on this board here, can't see this, according to the microcontroller, which is on this board here, to control the temperature of the tip. Okay, so this is the failed tip. It's still a little warm, but it's not like painful to touch anymore like it was when I first picked it up. If we measure the resistance between here and there, it's still giving me some resistance. 6 ohms. I measured this before and I got a different reading. 7 ohms now? Seven ohms. Okay, maybe this tip has recovered somewhat. That's interesting. So I measured it a few days ago and I got 0 ohms. don't know, maybe it's 0 ohms when it's hot. Maybe it was hotter the other day. Maybe as it gets hot, the resistance increases because it's still a little warm now. I don't remember how hot it was the other day. I don't think it was particularly hot, so maybe the resistance increases as it gets hotter. Maybe that's part of how the TS100 self-regulates. But either way, this is too low. It's less than the other one, which isn't warm at all, and this tip is still noticeably warm, if not painful. And if I plug it into my TS100, the TS100, because this tip is short-circuited, will put in the maximum amount of power into the tip. So you can see we're getting an error message on the screen. And if you give it a couple minutes, due to the failure of the tip as a short circuit, and the failure of the TS100, which caused the TS100's MOSFET to fail, the TS100 will always be putting 24 volts into this tip, which will cause the tip to glow red, as you can see here. So I'm going to clamp the TS100 and pull this out. As you can see, the tip is noticeably too hot to actually solder with, because it's freaking glowing red. There we go. So my supply is not current limited, which apparently is part of the problem. TS, to their credit, is going to replace this iron, even though I was using a non-current limited supply, and they tell me with the new iron to use a current limited supply, which means I'll probably just put a fuse on this, put a 5 amp fuse, because this is a 5 amp MOSFET, and then that should work. But this is why I can't do that much right now. I might still try to do some work on the big 3D printer, but I was trying to figure this out, so I should get a new TS100 within a week or two. And I also ordered some new MOSFETs, so we'll do some SMD soldering to replace this MOSFET and try to save this TS100 just as a little bit of fun. Okay, that's all. Thanks for watching, and see you guys soon.